Hello, Shake Ambassadors. Happy New Year. This is an exciting time where we, as all of our teams, are getting ready for the Shake Ambassador Club Shake Challenge. And our event, our final event for this school year, the Shake Challenge Symposium is happening in March 3rd through 5th. And I wanted to make this video to kind of go a little bit into detail about what you as a Shake ambassador can expect and what you and your team can expect going forward. Some details, instructions on the final project that you're going to present as a team at the Shake Challenge Symposium in Fairbanks. So I'll kind of go over. I have a little presentation. We're going to go over the details of the Shake Challenge Symposium, the final project instructions, single or double sensor system, methods to build the system, and then a timeline for the Shake Challenge completion. So for that project, and then go into a little bit of the agenda. What is this symposium event going to look like in Fairbanks? So the final project, as you've probably seen, is going to be a real-time seismic alert system, a warning system for a large seismic event. That's the instructions for this final project. Now, when I originally sent out these instructions, we had it to have 2 Raspberry Shake sensors. I've changed that, so now it's an option. You can do 1 Raspberry Shake sensor or 2 Raspberry Shake sensors that you're receiving live data from. And I'll talk about that. But what does this final project and presentation include? A presentation about your community, where you're from, what's kind of special about that. A presentation, including the presentation about how you built the final solution, the final project system. What program did you use? What challenges did you face? That kind of thing. And then a demonstration of the final system by jumping, of course. That's the easiest way to make a stomp quake. And I'll explain very quickly what that is going to look like. So I will show you here some examples of a system that you could use, that what I'm kind of talking about here. So when I say 1 or 2 shakes, so there's 2 options for the type of system that you could build. And when I say system, usually I'm talking about a computer, either a Raspberry Pi or a laptop, that you program to receive Raspberry Shake data from a live stream, this UDP stream data, and then process that. And you can have, there's 2 options. You could do a single sensor system where just with 1 Raspberry Shake is sending data to a Raspberry to a computer, and then that computer has a program that you build when it activates, when a major alarm activates when 1 sensor detects strong motion. So that's kind of the simple version that we're welcome to do. If you want to take it a level further, you can do a double sensor system where you have to have two sensors that detect strong shaking in order for this alarm to activate. And there can be a smaller internal alarm when just 1 sensor detects motion. So it has to be 1 sensor detects motion, and then it sets off a small alarm, and then if another one detects motion, then it's like, whoa, big alarm, major alarm. At both systems, regardless, you have a visual dashboard, so somewhere you can see the shape, the seismogram, see the wiggles, and then a visual and audio alert system, like some sort of alarm. So I'll show you what that looks like in a second. The ways you can build the system, there are a few ways. One is with like a Node-RED program. Many of you are familiar with Node-RED. There are some really great tutorials that actually talk about how to stream Raspberry Shake data to Node-RED. There's also this stuff is in the Canvas course if you're in that. But pretty much what you do there is you figure out what your IP address is, and then can program the Raspberry Shake. Either way, you'll have to do this. You program the Raspberry Shake on this configuration page. You can go to settings and then datacast and put the IP address of the computer that you want to send to and a port number. We just use 8888 often. And my laptop is 192.168.100.117. And I programmed a Node-RED flow to receive UDP data, have a UDP in, and then I followed the tutorial on T3 Alliance, tells you how to receive data, and then built a little bit of code here and put a live seismic data plot and then an alert system. So when it goes over a certain amount of shaking, then it'll send a notification and an audio. And this is all just within Node-RED and within the dashboard system. So here's my live seismic data dashboard. And look, it's set to have, when it shakes a whole bunch, alert earthquake. So that's pretty cool how it does that. You can see when I shake it around, you can see the live data, and there's a live thing here. So this right here, what this is like, you could present this, and this is totally, enough. Hopefully you and your team can make it special, and add some things, and of course, take it as far as you can. But this is an example of the simplest you could make your system to be. So another version of what you could do is something like what we see here with a program called RSUDP. Now this is a Python program that you can download online. There are some tutorials for how to download it onto a Raspberry Pi or a regular computer, or like a Mac or Windows system. I have it right now running on a Raspberry Pi, and what you do is you download it by going through a few steps, and then it's the same first steps where you're streaming the UDP data to this device, and there are settings that you can change with this program. There's all sorts of settings. You can, if you look here, it looks like a kind of a code file. It's a text file, and you can change settings. So do you want to have a plot? Do you want to have a spectrogram? Do you want to have it full screen? And it also lets you say, do you want an alert? And what type of alert? And when does it reset, right? And there's you can have an alert sound. You can program there to be an alert sound with this. And this is also a great tool to build your system with. So I'll demonstrate how it works right now. What you do is you go, after you install the program that you can follow a tutorial for, get it set up, and this is all through the terminal, the Raspberry Pi terminal. I'm going to go RS client, and what'll happen is there's a live visualization that pops up. Probably, oh no, something didn't work. No matching response information found. Well, let me go do something real fast. Let me go here and change this to Z000. This is all kind of what happens when you're programming. And go say, file, save, and then I'm going to retry that one. Control X, Control C, is that what cancels it? There we go, I canceled it. Now I'm going to try one more time. And hopefully it pops up now. This is an example of a live data feed, and this would also be a great tool to use for that live dashboard function. Now watch, if all of a sudden it starts to shake, see how it says detected events up here? If all of a sudden it starts to shake, I'm shaking my table, it'll say, oh, detected event, detected event one detected event, right? It'll do some sort of alarm system. You can actually change the threshold for how much movement needs to happen and that sort of thing. So those are some 2 tools. There are other tools you can use as well that are more custom built, and if you want to custom code, there's a lot of that. But anyway, those are a few options, and all of those instructions are in some tutorials. I guess, so for the completion of this Shake Challenge, we have pretty much exactly 2 months to get this done, like 8 weeks, right? Right now it's the first week of January, second week of January. We have until the first week of March. So from now on, it'll be really important that as a team, you meet weekly, at least weekly, to work on this. You can meet at school. You could also meet at somebody's house. The type of network that you use to program with the Raspberry Shake will it be important. Sometimes it's really difficult to work on a school network, so it might actually be easier to use either a hotspot or just go to someone's house and use the home network. Also, if that's not available, work with your site, your school network administrator. It's important that going forward, your team checks in with me weekly just about how you're doing. It could be a Discord message, it could be a video call, however involved you want to get, but just I want to be there to support you, and if you're falling behind or if it's being difficult, I'm there ready to help, and I would, it's important to stay together with that. The next one is the important checkpoint dates. So right now, I'm recording this on Wednesday, January 11th. By January 20th, Friday, January 20th, so next week, Friday, we need to have team members who are traveling confirmed. So if you're not sure, if you have, if you're thinking about it, you're kind of worried, try and talk with your team, talk with me. Let's meet together as with your team and me. We can decide on that. But we will be buying tickets the week right after, so it's really important that we have that. The week of February 1st, it's very important that you have practiced streaming UDP data. So practice that streaming either into Node-RED or into something, and started working on your prototype. Have like an idea for the prototype. Are you going to try to build your own? Are you going to use Node-RED and kind of fancy it up? Are you going to use the RSUDP? Maybe you could combine them, right? Start having an idea, and then starting a presentation, starting a Google Slides that you share with me and we can work on. Because this presentation that's going to happen in Fairbanks, we want to have practiced a lot and be ready. So then by February 15th, 2 weeks later, we want to have a prototype that's working and have a decision for the final design and be almost there, have a dashboard built, and then also maybe by then start kind of building out the rest of the presentation. And then only 2 weeks more and we're traveling to Fairbanks. So I guess I can add that here. March 3rd, travel to Fairbanks. So with that, I guess I'll jump to the agenda for this symposium that we're going to do. What will this symposium look like? So here we have the agenda. March 3rd through 5th at University of Alaska Fairbanks. This symposium event is designed to help you guys just be, just a fun, engaging time where you learn a lot, but also kind of have the experience of a professional scientific conference style event where you go and share your work, you learn from other people, so it'll be really fun. The symposium agenda, so Friday, March 3rd is a travel day, that's a Friday. So we'll get there in the afternoon and have some icebreaker activities, dinner, and then Saturday is a field trip and prep day where we will, in the morning, go and tour the Geophysical Institute, the Earthquake Center, and actually do a field trip to a local seismograph that's around near Fairbanks and with some professional seismologists. We will have all that afternoon to work on our presentations, to practice, to make sure our systems are working. Then in the evening, a fun time dinner, and then going out to the ice sculpture world championships that Fairbanks has. They're really cool. Then on that Sunday is presentation day. So early breakfast, and then doing last minute preparations in the presentation room before we start the stake challenge at 9:30, and go through actually until lunch. Students will present. Your presentations will be about 15 minutes, the teams, and then we'll have lunch, an award ceremony, a community research planning workshop. This is really exciting. It's where we get to talk about how we can implement all of the learning we've had. And then finally, closing ceremony, and that evening and the next day is flying back home. So really fast and fun and engaging weekend we have built out for everyone. All right, that's my presentation. And yeah, thanks guys. Let me know if you have any questions always. Stay shaken.